Okay, howdy. Just kidding. So rational zero theorem. This is so fun. All right. So recall that a polynomial function of degree n can have at most n real zeros. Real zeros can be rational or irrational. So to be rational means that a number can be written as a fraction. Not written, that's not, no. It can be written as a fraction. So that would be like 1/2, 4, 3/4, 7/9, 100, 101st, whatever, but it can be written as a fraction. Irrational numbers cannot be written as a fraction. So examples of those are pi, or e, or 4.19999764997, whatever, and just keep going forever. It doesn't have any pattern to it, okay? So rational zeros are those that can be written in the form of a fraction, or p over q. So the rational zero theorem can be used to determine all possible, holy moly, rational zeros of the polynomial function. So blah, 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 blah. P over Q. P, that's the factors of the constant term, or of a sub 0. The very last one, just the number. Q is the factors of the leading coefficient, or a sub n. Okay? So let's look at this one. We just need to list all the possible rational zeros. So a sub 0 equals -2. A sub n equals 1, because there's no number in front of that x cubed. So that means that p equals -2 and q equals +1. So then we're going to find p over q. The factors of 2 are just plus or minus 1 and plus or minus 2. And the factors of q is just plus or minus 1. So then the possible factors would be plus or minus 1 and plus or minus 2. And that's it. Okay, let's look at B. So a sub 0 is -18. A sub n is 1. So that means p equals -18 and q equals 1. So p over q, the factors of 18 are 1 and 18, 2 and 9, and 3 and 6. So it's plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 18. And q is just plus or minus 1. So those possible factors are 1, 2, 3, 6, 9, and 18. Make sure you're putting that plus or minus. I will mark it wrong if you do not. Okay? Let's do C. Now we do have a leading coefficient. Changes it a little bit. So a sub 0 is 1, a sub n is 4, which means p equals 1, and q equals 4. So then the factors of p are plus or minus 1, and plus or minus, just plus or minus 1. And then the factors of q are plus or minus 1, plus or minus 2, and plus or minus 4. So then my factors here, 1 divided by 1 is just 1. 1 divided by 2 is 1/2, and 1 divided by 4 is 1/4. So we have plus or minus 1, plus or minus 1/2, plus or minus 1/4. Cool. Let's look at D. So we have 3x cubed minus x squared minus 18x plus 16. My a sub 0 is 16. A sub n equals 3. So p equals 16, q equals 3. The factors of 16, 1 and 16, 2 and 8, and then 4, because 4 times 4 is 16. Factors of q are just 1 and 3, and plus or minus for all of those. So then let's first divide them all by 1, which is going to be 1, 2, 4, 8, and 16. Then we're going to go and we're going to divide them by 3 also. So then we also get 1/3, 2/3, 4/3, 8/3, and 16/3. And those are all of our possible rational zeros. Okay, you can do E and F. So now we need to find the possible rational zeros and then find the actual zeros. So our first step is to list all the possible rational zeros. So just what we just did. So a sub 0 is negative 8, a sub n is 1, which means p equals negative 8, q equals 1. So then we have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. And that's divided by plus or minus 1. So those are my possible zeros. Then we're going to test these zeros using synthetic substitution. Now, you can do that if you want. If you love doing synthetic division, go for it. But I think it's a little bit easier to just plug the numbers into f of x and see if you get 0. Because if you do get 0, then it is a factor, and then you can use synthetic division. Okay, so let's start with 1. So 1 cubed plus 3 times 1 squared minus 6 times 1 minus 8. So I'm just plugging it in to this right here. Okay, when I do that, I get negative 10, which that does not equal 1, so then 1 is not one of my zeros. Well, let's do negative 1. Plug in negative 1, and you do get 0 this time. That means that negative 1 is a 0. So x plus 1 is a factor because you just have to switch that sign to put it back into its factored form. So x plus 1 is a factor, and I would write that right when you figure out which one's a factor. And now I'm going to use synthetic division with that. So I'm going to have 1, 3, negative 6, negative 8 on the inside, negative 1 on the outside. Bring down that 1. 1 times negative 1 is negative 1. 3 plus negative 1 is 2. 2 times negative 1 is negative 2. Negative 8, positive 8, 0. So we get x squared plus 2x minus 8. Now we can factor that, and that factors to x plus 4, x minus 2. So that means that f of x equals x cubed plus 3x squared minus 6x minus 8. But the completely factored form would be x plus 1, x plus 4, and x minus 2. Then we need to find all my zeros. So I'm going to set each of those equal to 0. And you get x equals negative 4, x equals negative 1, and x equals positive 2. Okay? Let's do one more. So first we're going to list our possible zeros. Sorry. So a sub 0 is 18, a sub n is 1. So the factors of 18 are 1, 2, 3, 6, 9, and 18. Factors of q are just 1. So there's all my possible zeros. Now I need to figure out from my possible ones which ones are actual zeros. So we're going to test 1 first. And you get negative 54. Does not work. Let's test negative 1. And I got 0. So that one does work. And it's not always going to be negative 1. That is a coincidence. I don't know how that happened. But it's not always negative 1, so just so you know. But now I'm going to use synthetic division with our factor of x plus 1. So I have negative 1, 1, 3, negative 7, negative 27, 18. Bring down the 1. 1 times negative 1 is 2. 2 times negative 1 is negative 2. Negative 7 plus negative 2 is negative 9. 9, negative 18, positive 18, 0. So then that is x cubed plus 2x squared minus 9x minus 18. Okay? Now I can factor this by grouping. Because we have 4 terms, and remember when you have 4 terms, the way you factor is by grouping. So I'm going to group those first 2, group the second 2. I can pull out an x squared, and I'm left with x plus 1. Pull out a negative 9, left with x plus 1. So then that's x plus 1, x squared minus 9. Now that x squared minus 9, that's the difference of squares. So that factors even further to x minus 3 and x plus 3. So So then our f of x equals x plus 1 times x plus 1 times x minus 3 times x plus 3. And we have two x plus 1s because of this one and of that one. Okay? And you can simplify that just a little bit further. So it would be x plus 1 squared times x minus 3 times x plus 3. Then we have to find our zeros. So we have x plus 1 equals 0, x minus 3 equals 0, and x plus 3 equals 0. So x equals negative 3, negative 1, and positive 3. Okay, we're going to save those last two examples, or whatever, how many there are. And remember to take the quiz. Bye, guys.